How y'all doing today? I walked out of my office without bringing my lecture notes. I'm in trouble. So I'm going to be winging this the whole class. Sorry about that. Uh, wow. Okay, let's go ahead and get started. How y'all doing? How's everybody's weekend? I don't care. What is an algorithm? A series of ordered steps you use to complete a task. It's better than Who wants to tell me what a program is? Sure. An algorithm a computer and a human can understand. What is a computer? Does a computer understand it? It executes it, yes. Is that what you're going to say? There you go. Okay, so last time we had gotten through all the slides. We had gotten to the point that we were going to start talking about coding. And I believe that the first thing that I showed you was comments. Was that correct? What is a comment? Yes, sir. Exactly. It's like a side note the computer doesn't read. It's only for humans. And so when you put things in there, so I'm going to have to grab my notes off the computer. Excuse me for a second here. Let me stop the recording so I don't capture my password. All right, so we had talked about comments before as a note, and we had seen different things inside the example program. How many of you all been able to finish the homework so far? How many of you have had difficulty with it? Anybody in particular? Okay, what difficulty? Oh, you can't log on to the machine. Okay, here's the typical problem you have when you're trying to do SSH to csclass.uis.georgetown.edu. If you are on GuestNet, it will not work. If you are on GuestNet, the wireless network, it will not work. For some reason, UIS has decided that if you are on GuestNet, you are not allowed to connect to that machine. If you are in Nigeria in an internet cafe, you can. So if you're a scammer, you can connect to the machine, but if you're a student here, you cannot. And it makes me crazy because that's the problem people have in this class is they can't get it. So if you ever can't get on, look at your wireless network. If you're on GuestNet, you need to get on Saxonet instead, and then it'll work. So, other problems? Is that the problem everybody was having? Yes, sir. RM. RM is for remove. Yeah, RM and then the file name you want to get rid of. But use it cautiously. There's no trash can. Once it's RM'd, it's gone forever. So, okay. Other questions? Okay. So here's what we're going to talk about today. We're going to go through writing some code for different things. So what I'm going to do is I'm going to load up just kind of a blank program. Can you all see that? Do you want it to be a bit bigger? Is that good? Yeah, this room, the projector isn't as big as I would like. So let's talk about a few different things. Let me just take a quick peek at my notes and remember what we're supposed to talk about. All right, so we talked about basic data types, and we talked about the fact that when the computer stores something in RAM, it has a name, which is the name of the box it's in. That box has an address, which is a number, which we do not care about at all. And it has a type. And the type tells the computer how to interpret that particular series of numbers. Okay? We talked about a few different types earlier. What types did we talk about? Yes, sir. Integer. What else? Boolean. What's a Boolean value? True or false? Yes, sir, in the back. Uh-oh. Floating point, which is a floating point number, and a character, which is what? Anything you type like that. Is 9 a character? It can be. It can also be a number, and that generates confusion. Okay? So here are the different things that we've seen before. We have seen an int. We have seen, well, my editor's not going to do it. Let's call this integer. We have seen a float, which is a floating point number, which we'll call decimal. We have seen a bool, which is a Boolean, which we'll call TF, or true false. And we've seen a character, which we'll call, I don't know, what indicates a character to you all. No, E is horrible. Key, that's a great one, thank you. That was excellent, okay. Pardon? Key, I think he said key. It's great, I'm gonna go with it because it's great. Here's a candy. I've been eating too many of these myself, so I gotta give them away. All right, so these are the basic types: integer, float, Boolean, and character. Now, when we declare a variable, we declare it as one of these types. And as we'll see later, there are some other types as well, but we can declare it as one of these types. And when we declare it as one of these types, we give it a name. Okay? Now, not every name is valid in C++. So here's what I'm going to do. I'm going to save this. I'm going to go over here, and I'm going to compile it. G++ vars.cc.ovars. Okay? So this compiles the vars.cc program we're working on into a program named vars. Is this big enough? Does it need to be bigger? All right, silence is assent. You all owe me $5. Thank you, okay. Only one person doesn't owe me $5. All right, so let's see what this program does. What is our algorithm in this program? Yeah? We're just creating some variables. Are we using them? We are not. We are not using them. They sit there. So what does this program do when we run it? Nothing visible. Nothing visible, right? The program actually runs, it actually claims those boxes in memory, and then it goes, all right, I'm done, and gives up, right? We didn't output anything. Let's talk briefly about how you can name variables. When you name variables, it's pretty simple, actually. It's anything that starts with a letter. Let me see, let me just make sure I get this right. I gotta peek at my notes. See, I'm letting you see what I'm doing here, so, okay. Yep, so we have to start with a letter, a digit, or an underscore. A letter, a digit, wait. See, this is, oh man, this is when I have a bad day because I didn't bring all my notes. Okay, got it. So, when we declare these variable names, they have to start with a letter. There has to be one letter in the front. After that, it can be a letter, a digit, or an underscore. So let's take a look and we'll see with the compiler a few different things if it likes what we have or not. So let's say we have an int, too big a number. Is that a valid identifier? How many of y'all think it is? How many of y'all think it's not? Why is it not? Because it starts with a digit. It has to start with a letter. Then you can have digits and underscores. So this one's not good. I'll put a comment there. Okay. How about this one? We say int big 2 number. Is that one good? Okay. How about this? Int big number. Why not? You cannot have spaces. Okay? You cannot have spaces. The reason you can't have spaces is because that is how the compiler tells your words apart. So this one, put a comment here. So if you want to do something like that, what you need to do instead is int big number with an underscore. Okay? Underscore is common. Okay. All right, everybody kind of good with this? There's one other thing that will get you in trouble sometimes. The other thing that will get you in trouble is that C++ has what are called reserved words. That are words that have some special meaning to C++, and it doesn't let you use those for identifiers. So for example, say I say int float. Now, I don't know why you'd be naming an integer a float anyway, because that is kind of wrong. But you can see that my editor, which is somewhat fancier than your editor, has turned this word green, because my editor automatically turns the reserved words green. So I'm actually in a little bit of trouble here. If I go and I try to compile this, everybody see what I'm doing, by the way? I have my editor window open. This is Emacs. I think I talked about that last time. And then down here, I have the terminal window where I'm compiling things. Yes? Yes, vars is the name of this file up here. This is the file we're working with. You don't have to write everything down in here. I will upload this code so you can look at it and download it and play with it later. Okay? So vars is the name. And just in general, when I'm working in my editor, right down here in the corner, it tells the file name down in the bottom right. You probably can't see it unless you're near the front. Okay, how's everyone doing? Good so far? Any questions? Yeah? Yep. Nope. What the -o does is it says, here we are, I said G++ is the compiler. It says compile vars.cc, and -o means send it to the output file named vars. If I didn't have -o, exactly. And .a out is not very informative to me. So almost always when I'm compiling, I will use the -o so I know where it goes. Every time you compile it, you have to do it that way. So what's going to happen is when I compile again, what I'm actually going to do is I'm going to hit the up arrow on my keyboard, and there's a whole list of everything I've ever typed in there, because programmers are in a good way, right? And we don't want to have to type things over and over again. If I type history, I'll just tell you it shows everything that I've typed. And this is like keeping track of everything I've typed. If I want to do something over again, I can do !7. And what it will say is, out of all this list of the stuff here, do number 7 over again. Right? That'll work. That'll compile. Oh, no. But I got a problem because big number. Oh, I forgot a semicolon somewhere. What happened here? Oh, what ended up happening is it got confused by my thing down here that says int float, I suspect. So the compiler did its best, and I do clear, and that gets rid of the stuff on the screen, and then it compiled. So, okay. So everybody see what I'm doing here? This is one of the reasons that I don't just show you slides of code. It would be faster, but the process of programming includes doing all this stuff too, and if I don't do it in front of you, you believe it's magic and it's hard to learn. Okay? It's not. So everybody still good? Other questions about what's going on? Everybody's good. All right, so this is my compiling window. This is my editor over here. And what I was talking about are these different variable names. Big 2 number works, int big number works. Int float does not work. And it does not work because float is a reserved word. Okay. Wait, I've forgotten. That's better. Okay. All right. Everybody understand? When you declare a variable, it has a type, it has a name, the name has to start with a letter, followed by letter, digit, or underscore, as many as you want. It cannot be a reserved word. Yeah? Yes, you can absolutely start a variable name capital letter. Just very briefly, I will go into something that some people, when they declare variables, and it's actually some programming languages, use this style where there's like an underscore in the middle for big number. Other people use what's known as camel case. And camel case looks like this. And instead of the underscore separating things, you just capitalize all of the words that make up your variable name. Because we're going to talk about variable names, what we really want for our variable names is for them to explain quite well to other people who are reading our program what that thing is, right? As we see later, we're going to have some things where when you're coding, if it just says X or P or Q or something like that, that's great if you're a mathematician. How many of y'all are mathematicians? How many of y'all are humans? Mathematicians can be humans too, it's okay. So right? Humans generally do better with longer variable names. And sometimes you require multiple words to kind of get your idea out. Like on the first homework, right? When you were all figuring out the price per square inch of pizza, did you all call that price per square inch of pizza, or did you call it P? How many of y'all called it P? Oh, no. Price per square inch of pizza. You want your variable names to be descriptive. That being said, you don't want them to be like 50 characters long, which happens sometimes. So. Okay, so this one right here is what's called camel case. In this class, I will probably generally use the underscore. Different programming languages have different traditions. How many use Java? Java is like camel case most of the time, right? So it just depends. All right, everybody good? Other questions? You're asking good questions. I like them. All right, when we declare a variable, what is the thing that we should do when we declare it? Yeah. Assign a value. Why is that? Exactly. You don't know what's going to be in there if you don't assign a value. So I'm going to output big 2 number right there. Is big 2 number initialized? Have we assigned it a value? We have not. What is the output going to be? Anybody want to predict what number it will be? All right, I hear 0. Some people are saying 0. It's most likely to be 0, in my experience. However, you can't guarantee it. It depends what's been going on inside your computer. So, most likely it's going to be 0. And this creates problems because sometimes you'll run it and it'll be 0, and other times you'll run it and it will not be 0. And if you've been running it for a while and you've been happening to get zeros and you think everything is happy and then all of a sudden it starts not working because it's not 0 anymore, then you're in trouble. So what do we always do when we declare a variable? We should try and initialize it, just as a defensive coding measure. We want to protect against the fact that we as humans make errors. And if we always do the same thing, if we're always in the habit of doing it, we will probably not make the error. Okay? All right, so what are we initializing these things with? We use the equal sign. The equal sign, the single equal operator is known as what? The assignment operator. It assigns a value from the right side of the equal sign to what's on the left side of the equal sign. Okay? Yeah? No. If you have some other reasonable value to initialize it to, you can initialize it to whatever you want. My habit for integers is 0. I generally do the same thing for numbers. Characters, it gets maybe a little bit trickier. And then bool, I normally set false, just as a habit. Doesn't always save you if you make a mistake someplace else, but it does save you from this weird thing where it gives you zeros for a while and then stops giving you zeros. Okay. All right, so this equal sign is the assignment operator. This 0 is what's known as a literal. It is a literal value. An integer can hold a lot of values. 0 is literally one of the values it can hold. Okay, so you can assign a value that's a literal. We can assign something to decimal. This one we can say 0.0 because it takes decimal places. For bool, we can say true or false, which is kind of nice. You can also use 0 or 1 if you want. And then for character, what you can do is just put 2 quote marks next to each other, and that's kind of like a null character. It means no character. But you've assigned it something, and the things you've assigned it is nothing. Let me just make sure this compiles, and I'm not gone insane. Oh, okay. So how about we just put a space in there then? Sorry. I switch back and forth between languages, and I sometimes confuse language features when I haven't looked at them for a while. So for key, we'll just put a space in there to start. Okay. In this case, I just did it for true as you want, but we can do it for false. That's better. So, okay. Clear this. Make sure we're still compiling. Good. Our code is syntactically correct. That means it compiles. It's not necessarily semantically correct because it may not do what we want it to do. Okay. Yes, sir? Let's try it. This is the beauty of having the computer, right? Is that you have an oracle that will answer all these questions for you, but I suspect it will not compile because it will be like warning multi-character constant, warning doesn't work. So it actually did compile. When you get these things that say warnings, it actually compiled, but it doesn't mean your program's going to run correctly. It probably means your programs might do something unexpected. Okay, so that's what happens when we put two spaces in there instead of just one. Other questions? All right, let's take a 1 minute break in place. Ready, set, go. All right, I've already noticed that nobody's standing up on the 1 minute breaks. I really encourage you to stand up. Seriously. You have 10 seconds. You can just stand up and sit down again. Really, it'll help you think. It helps you concentrate. Great, sit down, sit down. So, you should. When I give you a break, just stand up. It's too long to sit for like an hour and so long. So. All right, so let's talk about some other things. Here we have been defining our variables, one on each line. We can define variables by putting multiple variables together at the same time. So we can do int x, y, z equals 0, for example. Anybody want to guess what this line of code does? Yes, sir. Okay, his answer was it declares x, y, and z all as separate integer variables and sets them all to 0. Anybody think that's right? Anybody think that's not right? Why is it not right? Yes, in this one, only z is getting set to 0. It is trickery and fooling you, okay? If you want to initialize all of these to 0, you have to do it each one individually like this. Okay. They will all be 0 now. I'm just gonna, I like compiling frequently just to make sure I haven't done anything wrong here. So, okay. You only have to say int once, and then you can define as many of those variables as you want as long as they are separated by commas. If you want to initialize them, each one has to have its own separate equal sign. Okay. Yes, sir? Can you have code past the semicolon? Let's try it and see. All right, is that past the semicolon? Is that what you had in mind? Let's see what happens. Sorry, I don't know why it turned to blue there. All right, clear the screen. We'll compile it. We will run it. Oh, check this out. What's this giant number right here, by the way? Do you remember we were printing out that big number, which was 0 last time? Look, now all of a sudden it's this number. That's a happy accident. I don't always get to show you that. I'm glad that's there. But to answer your question, yes, you can have code after the semicolon because the compiler doesn't care about white space. You could take every single space, almost every single space. You could take every return out of here, and the compiler would like it. But who would be unhappy? Humans. Humans who had to read it would be unhappy, right? So, all right. So, and just to show you again what happened, right? We printed out, does this work? It was after the semicolon, and down here we declared this int big number, big 2 number, and we output it. And look, big 2 number now is 191,562,944. That was just what happened to be in memory where big 2 number was. That's it, just randomly. Remember, I said that sometimes it's 0, most often it's 0, but every once in a while it switches to something utterly bizarre. There is your example of that. And that made my whole day. That's almost worth losing my notes for. Yeah. Yes, yes. That's Anytime you change it with the equal sign, it changes. It can never go back once it's been assigned. Right now, right now what happened is we said, hey, go in and find a box and label it big 2 number, and it's going to be an integer. And the compiler said, okay, and it grabbed a box. And there was something in there, like some bunch of zeros and ones that meant something somewhere. But what ends up happening is we go to print it, see how it goes and looks in that box, and it says, oh, here's a bunch of zeros and ones. I will assume they are an integer, because that's what I told us, and I'll print it, and we get out 191 million, whatever it is, okay? That's why we initialize things, because otherwise our life is going to be sad. Our program will behave unpredictably, because sometimes if you're expecting it to be 0, when it's not, it's something else you get in problem. Yeah. Would it make sense to initialize your variable with your intended value from the start? It would if you knew what it was. It would if you knew what it was. If we're going to get user input, we do not have like the Miss Cleo psychic hotline where we can figure out what the numbers the user is going to give us in advance, but we can still initialize it as a defensive precaution anyway. Now you bring up a good point though. Let me show you one other thing. Here is the other thing. Let's say we're going to have this thing right here. We're going to have a floating point number. Right? That might be a number that's familiar to some of you. What number is that? Oh, come on. No way. Oh, you're right. Sorry. 1415. Sorry about that. 314. Okay, 31415926255. Okay. Close enough, right? All right. All right. We'll see how you're doing here. Oh, you're right. I put an extra 2 in there. Ah. All right. We'll go with this. This rounds are okay. So E, Euler's constant, right? Now, how often in your program are things like this going to change? Like if you have something like pi or E, or it's a well-known value, right? How often are you going to change them? Right? How often are we going to change these things? Probably never, right? Unless you're like some crazy physicist doing physical simulation models of the universe and you need to change constants to see what would happen if the universe was created differently. You probably don't need to change these. What could go wrong with this in a program? Yeah. You can accidentally assign it a different value, and we'll see how that can happen later, right? It would sort of suck if you were running along in your program and pi was no longer what you expected it to be, but was instead some other value by accident. Would that be bad? So there's a way we can fight against that. And the way we fight against that is we put this in front, const. When you put const in front of something, it means that once that value is put in the box, it is not allowed to be changed. Okay. So variables vary. They can change values. Constants cannot change value. So let me just show you this really fast, okay? So let's compile and make sure I haven't introduced any crazy errors in here. I haven't, right? The compiler doesn't yell at me, so things seem to be working. We can run the program vars just once. Oh, look, we got a different value for big 2 num there. It's awesome. Now we're at 400 million, right? So this is why we initialize things. Let me try and do this. Let me say pi equals 3. Because obviously that other one is too challenging for me. I want to make it a lot simpler, a number that I can handle, okay? What happens when I do that and I try and compile? Error. You cannot assign the variable pi because it is a const. Const, right there. You cannot do it. So that helps you keep from getting in trouble. When you are working with code that has values that are specific to whatever you're working on, you should put them as const. Okay, you should put them in const. In fact, when you declare constants, they should be, just as a matter of style, one of the first things you declare at the top. The reason for this is when other people come to read your code, and they're reading through your code, and all of a sudden they see you refer to pi or e, they go, I have no idea where that is. If you've declared it at the top as a habit, then that's kind of just a standard. It's like the table of contents in a book, right? We always put that first instead of somewhere in the middle so that we can find things easily. You always put constants at or near the top. Okay? The other thing that some people do, and this is sort of mixed these days, but it used to be more true, is that if something is a constant, it is all uppercase. Except I just made EI, I'm sorry. You know what, I'm going to make this a little bit different. So. That, then when people are reading your code, if they see something that's all in uppercase, they go, oh, I know that's a constant because it's all uppercase. Okay? This is a style thing. Not required, but it makes your code more readable for other people, which is what we want. Okay. Everybody good on this so far? All right. Just take a quick peek at my notes. Remember what else we have? Constants. Okay. Now, so far we have talked about assigning initial values with literals, right? Only assignment we've done so far is to assign a variable to a literal. Is that the only thing you can do with assignment? How many of y'all think there's other things we can do? Yeah, that's just like a trick question, right? Because we would stop class if I were asking that or something. Okay, so let's say we've been looking at this big 2 number and we've been really unhappy that we're getting completely random values for it every time, and we want it to be something that we know. What we can do is we can assign it either to a literal or we can assign it some other value. So here what I'm doing is I'm saying int big 2 number, I'm declaring a new integer, and I'm setting it equal to integer. What is integer? Integer, well, the value that you get from doing this is 0, but what is integer? Nope. Integer is another variable defined up here that has a value of 0. So here's what happens. This runs and it says, okay, int big 2 number, grab a new box. It's going to be an integer, put big 2 number as a label on it, and I set it equal to integer. It goes, integer. What is integer? It's a variable. Oh, it's this box over here. So I will go and look and see what's in this side, the box named integer, and get that value, which happens to be 0, and then assign it into big 2 number. Yes, sir? They have 2 different memory addresses. Yes, there'll be 2 boxes. There'll be one box named integer, one named big 2 number. Have you programmed before? Pointers? All right, never mind. Okay, we'll get there. Remember, that's the part of the graph where things get challenging towards the end of the semester. Okay. All right. Yes, sir. Yeah. Nope. So the question was, if big 2 number, for example, we print it and it's like 400 million in there, is that value being used someplace else with the computer? And the answer is absolutely not. When your program runs, the operating system, Mac OS in this case, gives it its own dedicated chunk of memory. It's not being used by any other program. I'm lying, but for the purposes of, unless you explicitly say I want to share this memory between a bunch of programs, it gets its own one. We're not at the point in our programming career where we're sharing memory yet, okay? So each program gets its own chunk of memory. Now what happens is there's some leftover stuff that was used by some other program before, but it's leftover. It's like you go to the dining hall and you sit down, and if people have been nice, they've cleared their trays away off the table, but sometimes you sit down and other people's trash is still there. It's not being used, it's just left over, and you have to do something with it. Okay. All right. Everybody good so far? All right. So this is really important, right? This fact that we can just give a variable name is important. Okay? Just calling a variable name by name means that the compiler is going to go and look at the box that has that name and replace that value with what's in the box. I'm sorry, replace that with what's in the box with that name. So in this case, it's saying, oh, well, we're going to set something equal to integer. I got to go look in this box up here, and I find out that it's equal to 0. So this whole thing, this whole word integer down here, becomes 0. It essentially gets replaced with 0 based on that memory lookup. Yeah? Mm-hmm. Okay. The question is, if we declared big 2 number as a character instead of integer, what would happen? The answer is we'll find out later. Yeah? Okay, so then the question is, say later we change integer right here. What happens? So let's print some of this stuff out and make sure that it's going the way we want, okay? So here's what I'm going to do. I'm going to label this so we can see which is what. So I've added the word big 2 number to the output here, okay? And if I compile it and I run it, oops, that didn't run it. We say, does this work, which we added before, and we have big 2 number is now 0. All right? The nice thing about this is no matter how much we run this, it's always going to be 0. We're not going to get any more of those 400 millions. And the reason is because we've done the assignment here before we output it. So it will always be 0. It won't have random numbers anymore. So the question was asked, okay, if we set big 2 number equal to integer, what happens now if we change integer? Is big 2 number going to change as well? What do y'all think? How many of y'all think yes? How many of y'all think no? All right, let's see who's right. So I will compile the code, and I will run it. And look, big 2 number didn't change. Now, in fact, we can, just to make this easier, I can put integer in here too so we can see what's going on. And I'll put it down here after it's changed, and we can see for sure now that one of them changed while the other one doesn't. So I will compile it. It compiles cleanly. I will run it. And you can see integer was 0, big number was 0, integer changed, and big 2 number stayed the same. Okay? Remember, each one of these has their own separate memory boxes. They are not linked together by the equal sign. What happened is the value gets copied from one to the other. Okay? Who's with me? Who's against me? Okay, what's your question?
So, say that after we assign a new value to the integer, and then again we assign, say, big 2 number equals integer, will that copy the previous value?
Nope, it'll copy whatever's in there. As this program goes on, you can think of it this way, right? If I look at the listing of the code over here, what you can think is as this, this is just like a flow chart. Remember we talked about flow charts for algorithms? What is the first thing you follow in a flow chart? Start, right? What is start in C++? Int main, right? So right there, this is start. And what we're going to do is as the program runs forward in time, it's going to go this. First line, it's going to declare a box named pi, that's a float. Next, it will declare a box named Euler, which is a float and has that value in it. It'll declare a box named integer, it'll declare one named decimal, it'll declare one named TF, it'll declare one named key, it'll declare one X, Y, and Z. So here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, or 10 boxes done, right? Those values Just think of it this way, right? Time is going from top to bottom. Values change. Once they have changed here, they are changed from there on. Okay? It's just like the flow chart with that little line that you follow around. Well, the line in this one goes from here to here to here to here to here to here to here. When something changes inside the box, it stays changed. There is no going back. Yep.
So it's basically a way to save a value. Since you said that once the box is changed, that's
Yep.
basically a way to be able to go back and look at what it was before.
There's no way to go back.
But if you save it to another box, like
Yes, if you save a copy, someplace else and the copy is not changed, it will be the same. But you cannot really go back. I'm lying about the not going back part. We won't reach that in this course. It's entirely something very advanced. So, okay? But you cannot go back. Yeah? Sure, I'll step through the whole thing. Let's just step through this code and see what it does. We're going to be doing a lot of that this semester. It's fine to do it right now. Where do we start? Come on. Where do we start? One more time. Where do we start? Where do we can start at int main. I mean, this stuff all goes together. We'll talk more about that stuff. We start int main. The first thing, in fact, you know what? I'll even draw this on the board if it helps. It won't show up in the lecture. So the first thing we need to do is we declare a box. What's its name? What's in there? 3.1. All right, the next thing we do, we've done this line. We've reached the semicolon. Where do we go? Next line. What do we do here? We declare a box. Its name, it's Euler 2.7, da 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 da. Oh, what type is this first one? I'm just going to put an F for float, an F for float there. All right, next step, what happens? We declare, we get a box. Its name is integer. There's a 0 in there. It's an int. Okay? Everybody with me? Okay, next box. We get a float. It's 0. Its name is decimal. My handwriting is terrible. Okay. Next one. This one's a bool. Its name is TF. What's in there? False. Right? We're declaring these boxes one by one. They have a type. They have a name. If we initialize them, they have a value that we know. If we don't initialize them, they have some value that we don't know. Okay? All right. We do key, which is a character. We do X, Y, and Z. All these are zeros, and they're all ints. All right, that's everything on this, right? What do we do next? We output, does this work? So that gets output. Then if we keep scrolling on down, we declare some other stuff, right? We declare this box big 2 number. And when it comes time to declare it, what value do we put in there? We go, oh, we're setting this thing equal to integer. What is integer? It's a box right over here that has this value in it. So what the compiler does, what the program does, is it says this integer gets replaced. The word integer gets replaced with the value that's in the box named integer, which is 0. So big num now, big 2 num is 0. Okay? All right, we output this line. It says integer is what? What do we do next? Go to the next line. Big 2 number is what? Okay, now we say integer equals 1828383. What happens? What happens is this box right here named integer that used to have a 0 in it now has another number in it, which is 1828383. Okay, it changes that number. Now, did the box over here with big 2 number change? It did not. It's its own separate box. It has its own name. It has its own value. All this thing right here is when you say integer, here's what it does. It does the same thing for cout, by the way. Right? What cout does is it says output integer. This double quote means it's a string literal. A string, which we'll learn more about, is a whole bunch of characters in a row. And it says integer. When it sees integer, what does it do? It says, aha, this is a variable name. It refers to a box. It goes over here and it looks in the box and it says, oh, the value is 128383. And so it will output 128383. It'll go here and it'll say big 2 number. It'll output that string and it'll say, oh, big 2 number, that's a box. It's a named box. I know, I'll go look in that box. What's in there? 0. It will output 0. Okay? And if we keep going, you'll see it define some other variables and stuff, but we don't really care about that. Yeah?
So if you wanted to reassign big 2 numbers value, you'd have to put like int big 2 number equals integer after assigning.
Okay. Let's try it. So right here, what we're going to say is if we want to reassign this, she suggested int big 2 number equals, what do you want it to be? How about that? Does that look good? Why doesn't it look good? How many of y'all think it's good? It's perfectly reasonable to think it's good. How many of you think it's not? How many of you have your hands up already programmed before? Okay, so here's the deal. When you put int in front of it, it means you're declaring a variable. What's happened is that we already have a box named big 2 number. So if we try to compile this with the int in front of it like that, what's going to happen is the compiler is going to say, uh-oh, wait a minute. You can't have a second box named big 2 number. Because if you had 2, how would you tell them apart? Right? Like children or twins. Okay. All right. Anybody a twin here, by the way? You are? Identical? Does your sibling go here? Oh, okay. By the way, I had a class. I had a twin in my class like 2 years ago, and I would pass their twin going the other way every single day going to class. It would baffle me because I'd walk by and they would be in class even though I just walked past them before. I did not. And so finally one day I twigged and I was like, are you a twin? And they're like, yeah. And I go, what's your twin's name? And they told me. And then every day while I was walking down, I would call the twin by name. I'd be like, hey, Tom. And he'd be like, hey. And after I did that like 10 times, he'd be like, how do you know my name? Anyway, sorry. Okay. I have no idea why I said that. Did I answer whoever's question there was? So the problem is if we try and redefine it, it'll be a problem. But if we get rid of the int in front, it's no longer an assignment. I'm sorry, it's no longer a declaration, it's assignment. And now what it'll say, okay, I have this number. Where do I put it? Oh, I'll put it in the box named big 2 number. So you can change it that way. Does that answer your question? Yeah. Uh-huh. Yep. So after here, if we've redeclared integer to be 1828383, and down here we did big number equals integer, it would now be that number. Okay? As things goes on, anytime the code executes, it will execute and pull whatever's currently out of memory. Okay? What I'm doing here, how many of y'all this seems really simple and like it's kind of boring, right? Did I warn you in the beginning of class that we would go slow and it would be boring at first? The reason is that you really have to understand this stuff. Otherwise, later in the semester, you get crushed. So we're going to go at a speed to make sure everybody understands the basics so that people don't get crushed later on. All right? So this is what you do. Every single step that you're going. The other thing, remember what does a computer do? Like what can a computer do in hardware? And how does it do math? It takes some numbers from memory, it adds them, it puts them back. That's all we're doing right here. The way we're taking numbers from memory is we're referencing them by name. We're doing something with them, and then we're putting a value back. We're not even adding yet, but we'll get to that. Okay. Thumbs up? Any questions at this point? 17-second rules in effect. 17, 16, 3, 2, 1, 0. Okay, any questions? Great. 1 minute stand up and place break, okay? All right, 1 minute is up. How many of y'all feel better? It's a lot better to stand up, isn't it, than to just sit there and quiet for a minute? Okay. So, oh man, giving all my notes away. Okay. So this concept here is that everything everything that is a value. Let me think about this, how to describe this. Everything in C++ has a value and type. Okay? If we were just to put this line right here by itself, what would happen? So we set right here, we set big number equal to 19828. Down here we just say big 2 number semicolon. What does that do? Yeah? Okay. It sort of doesn't do anything, right? It doesn't do anything in the sense that no values are changed because we didn't use an equal sign. Nothing is output because there's no cout. But this actually does something. The computer will do something when it sees that. What does it do? What it does is it says, oh, big 2 number. I know what that is. It's this thing over here. It's this box, which at this point we've actually changed to a value of 800. It goes, okay, it will replace this big 2 number with that value, 19828. It will go, okay, I know this. It'll put 19828 semicolon, and then it'll go, all right, I'm done. That's it. It doesn't do anything in this context, right? It will go and get that number. It will say it's an integer number, 19828, and it won't do anything. Now, if there was an equal sign next to it, would it use that number for something? Yes. If there was a cout, would it use that number for something? But you have to understand, and this is crucial, that anytime you refer to one of these variable names, the computer goes, oh, I know that variable. It's right over there. I will go get what's in that box with that name and bring it and put it right here. Okay? Even if you're not using it for anything, if you're not outputting it or doing equal, anytime it sees that variable name, it will go and get something out of the box and bring it back. Computers are dumb, right? Is this something dumb to do? It is, but they're dumb incredibly fast. Okay? So the computer will do what you tell it. You say, hey, go get the thing out of the box. It goes, okay, here you go. And you're like, I don't need it for anything. He goes, okay, I'll go on to the next thing. I'm good with that. Doesn't care. Dogs are smarter. Dog would be pissed at you, right? Dog would be like, what? So, okay. So everybody good with that? Everything, any variable you see actually has a value and a type. Any variable name has a value and a type. If you haven't initialized it, you may not know what the value is, which is why we like to initialize things. But every variable has a value and a type. Okay. Here, up here where we said big 2 number equals integer, we're using that number and type to change the value of big 2 number. Here, we're saying, oh, here's a real number, put it in the box named big 2 number. And here we're just saying, go get it and bring it back and then totally forget about it. The computer's happy to do that. Okay. Super important. Everybody sees that these variables refer to boxes with numbers in them? Yes? Thumbs up? Okay, good. I can go on to something else. All right. So once we have these numbers, I'm going to save this. I'm going to start a new file to work with, okay? All right, once we have those numbers, we can actually do things with them. What kind of things do you think we can do with them? We can do what? Math, all right? So this file is called math.cc, and we're going to talk about some of the things that we can do with these numbers. So let's just get a couple of numbers for fun. Who wants to have 3? Wait. Okay. So I created 2 integers. One's named X and one named Y. Is the font too small? Is that better? Yes? Silence is assent. Everybody owes me $20. No. Is the font big enough? Okay. All right. So, yes? Okay. Style. The question is, why is there an indenting here? Inside the main function, everything should be indented a little bit. My editor does 2 spaces automatically. You can be a tab. Some people use tabs. Some people use 4 or 8 spaces. The idea is that later when our code gets more complicated, you will see different parts will be indented differently. It's kind of like having paragraphs in a book. So you can kind of like see things better. It makes the code more readable. Okay, so the question is, why do we indent? Okay. All right, so what does this code do so far? What is our algorithm here? Somebody who hasn't answered a question in a while. Pick on somebody. All right. Yes, sir. What are the names? Are they initialized to anything? Okay, so step by step, what happens? Declares x, starts the function, declares x, sets it to 3, declares y, sets it to 2. Okay. All right. So our algorithm is we just declare 2 variables and give them values. Okay. What can we do with these variables? Can we what? What do you think that does? Int z. This says we're declaring a new variable because we put the type here, int z equals, what is this initialized to? X times y. What's 2 times 3? So what is z going to be? Okay. So this is multiplication. Let's try z equals x divided by y. What is this? Division. All right. What else do you think we can do? Okay, so the question is, will that come out as a fraction or not? Let's just go on and let's ignore that for now. X plus y. Subtract z equals x minus y. Some programming languages have a power operator. C++ doesn't have a power operator. So you can't really do power. All right. So who is getting a little fatigued? Anybody getting, yeah, question? Go ahead. No, you don't have to put a space there. I just put it there because it's easier for us to read. That's all. All right, who's getting a little fatigued? Who's ready for lunch? Anybody need a snack? All right, why don't you come on up? Who else? Who else needs a snack? Come on up. Anyone else need a snack? Come on up. All right, so it's your lucky day today because I brought you all a snack. Here is a piece of cake. I wanted to get a cupcake. Come on over. Here. There's a piece of cake. I've got some forks and napkins for you. So you all get to split this piece of cake. Who wants to do the honors of cutting it up? All right, well look, here I have a knife for you too. All right, so go ahead, cut that into 3, try and make it equal. You know, to be fair, one of the others should have first choice of which piece they get. So whoever cuts gets the last pick. Okay, so here's some napkins. You can put your piece in a napkin. Which one do you want? Yeah, sorry it wasn't cupcakes. You want your piece there? Do you like the icing piece or the middle? Oh, I would totally take the icing piece. Good, good. There you go. Here's some napkin for you to wipe your hands. Here's some forks to eat it with. There you go. Okay, so what did we do there? We divided the cake into 3 pieces of it. Okay, so who else wants a little treat? Anyone else? Come on, raise your hands, volunteers. Come on, Roberto. Who else? Come on. Look, they got cake. What do you think's going to happen? 1, 2. Anyone else? Come on, I need a few more. Come on up. Yeah, come on up. 5 people. That's great. Okay, so here we go. What I need you to do is divide yourselves into groups of 2 really fast. All right, groups. Oh, this is a problem. All right, so we have 2 troops, and listen, I'm sorry I don't have a bigger knife. It's going to be really, really painful. But do you want to do the honors? So, all right, we can cut cake up, can't we? Can we cut people in 2? Can we cut people in two? In theory, we can. In practice, cutting people into two is limited to surgeons who are dividing cojoid twins. Okay? So we don't really cut people in two. So thank you for your volunteers. You should have volunteered first time. All right? The whole point of this is to show you there are different kinds of division. There is a kind of division where we can cut things up into small pieces. There is a kind of division where we cannot cut things up into small pieces because whatever we're dealing with is not amenable to being chopped into, right? Do you see the difference between that? How many of you understand the difference, that there's different types of... Okay, so in the computer, when we do division, we have to specify which type of division we're doing. Okay, we have to specify which type of division. Now, the way we do that sometimes is a little bit confusing. Here's what happens. In division, an integer divided by an integer is an integer. It is integer division. It will not show you the remainder. It's essentially like doing division, right? When we had 5 people and we split them into groups of 2, how many groups did we have? When we had 5 people and we split them into groups of 2, how many groups did we have? And we had 1 left over. So if we do, let's just change x up here to 5 for fun so we match. So if we do, right down here, we do 5 divided by 2, what do you think the answer is going to be? 2. It'll be 2 because we're doing integer division. If either one of these things is a float, if any one of those things, either the numerator or denominator, is that the right term? Ready for kindergarten math. Okay. If any of either the numerator or denominator is a floating point number, you get a floating point result. But if you divide 2 integers, you get an integer result. Everybody see that? So, integers, if you int divided by int, you get an int. And you have a remainder that you can figure out separately. If either one of these things on top is a float, you get a floating point answer. So let's take a quick look at this a little bit more in the time we have remaining. What do you think z is going to be right here? All right, so what this is going to do is going to output z. Let's just make sure. All right, so if we run math here, we can see z is 2. Everybody go with that? Is that what we expected? Okay, so here so far we only have some integers. Let's give ourselves a float. Q equals 2. Okay. All right, now let's try this one. What happens if you do q equals x divided by y? Remember, q is a float, right? Q is a float. What do we get? How many of you all say, look, this is a floating point output. We're doing x divided by y, 5 divided by 2. This is a floating point answer. What's the result? Let's look and see. Let's look and see. Obviously, we have some sort of disagreement on this because, whoops. I'm just cutting and pasting code a little bit so I don't have to type as much. If I'm ever cutting and pasting, I do something wrong, please let me know. Okay, so z is equal to x divided by y. Z is an integer, x is an integer, y is an integer. We saw that this was 2, it was integer division. Q is a floating point, and now it's doing x divided by y. what are we going to get? We'll compile it. We'll run it. It is also 2. But wait a minute. Wait a minute, wait a minute, wait a minute. Q is a floating point number. Why is it 2? Because x and y are both integers. It doesn't matter where you're sticking the result. What matters is what two things are doing the division. Okay? What type is x? An integer, it's declared up off the top of the screen. What type is y? All right, so with our little table here, integer over integer always gives you integer. Now the computer is automatically going to change this integer to a float for us and stick it in Q, but it loses the half part. It just loses it, okay? All right, but if we go up here and we put some other things, let's say float O equals, O is horrible. Let's do n equals 5, float m equals 5, m equals 2. Then we can down here, and if we try again and we say we go down here, now we say Q equals, what did I call it? N over M. What? Oh, thank you. Q equals N over M. You all are better than the compiler. You're much politer, too. And then we see out Q again. What are we going to get this time? Why are you saying 2.5? Because N and M are both floats. N is a float, M is a float, float over float equals float. Okay? So when we print this out, we should get something that looks like 2.5. And we'll run it, 2.5. Yay. Yeah. We'll talk about that later, but yes. If you take a floating point number and you try to stuff it into an integer, you just lose all the decimal places. If you had a number that was like 4.9999999 and you stuffed it to an integer, it would be 4. Okay, we'll see that later, but just so you know. Yep.
If you have like a repeating decimal at the end in like a float, does it ever cut off or does it just keep going?
The question is, if you have a repeating decimal in the end, does it cut off or does it keep going? The answer is that it cuts off. Because remember, each box is a particular size and you can only hold as many decimals as fit in the box. So, okay. All right, so let's try another one here. Those were easy, right? Because those were, this is, yeah? We'll talk about that, yeah. I'll just as a quick aside, some languages do this. They use that caret as the power. C++ doesn't have that. You can compute the power, but it's not like an operator like plus or minus or division. So, okay, so we figured this was floating division. All right, check this out. Now I'm going to get confusing on you. Q equals x divided by m. Let's put some spaces in there. What's this one going to be? Q. What's this going to be? X divided by m. Why 2.5? Because x is an int, m is a float. Int divided by float is float. So if we output this, we'll see 2.5 again. 2.5. All right, so things we'll learn today. Everything is an expression. That means every variable name gets replaced with a type and value if you use it in your program. Equals copies that value from one side to the thing that's on the other side. We've learned that you can't cut people into pieces legally, except under very limited circumstances. We've learned that the first people to volunteer get the better treat. Anything else? Standing up for a minute helps. Doesn't it help? It really does, doesn't it? All right, have a good Tuesday. I will see you on Wednesday. Make sure you get your homework done by then. The first programming project will be posted on Wednesday.